Good morning, everyone.
Good morning, sir.
Okay, so you can hear me?
Yes, sir. Yes,
Oh,
sir.
okay, so let us continue. Okay, last class I think we done with the servo motor, right? Was it rotating servo motor in the for loop? Okay, so now we are going to do one or two more things in the servo motor part, and then we are going to start with the temperature sensor. Okay, yeah. So all of you can see my screen, right? You can see my screen, right? No, no, I will be doing on Tinkercad. You have to do it physically. Okay. Yeah, yeah, you can take it out. That horn, the servo horns which connect on it, connector on the servo, white color thing. Just give me 1 minute, okay? Um, so just a minute, guys. Okay, so let us start. Okay, just a minute. Oh, jolly, jolly. So I will be making the circuit on Tinkercad. You have to make it physically. So just take. So just we are going to change in the code little bit so that we can just move the servo back also. Okay. Yeah, yeah. Join again. Yeah, this is basically you need to connect the red wire. Okay, wait. Red wire to 5 volts, brown wire to GND, and orange wire to digital pin 5. Red to 5 volts, brown to ground, and orange to pin number 5. Yeah, no, no, no. Last class you put the code, right? How you remove the code? Yeah, that is fine. If you're closing the tab, that code gets once the code get uploaded in the Arduino, it is present in the Arduino. It doesn't matter whether you are connected to the. You can't. That's what I told you. You can't stop it until and unless you are just plugging out the power supply. Yeah, maybe just upload a blank code. Yeah, that would be also. Yeah, nothing. Like it's additional this one, na empty section. This one is to just unused. You can see this is unused one. So it's just like if you want to connect any one of the pins with this, you can connect it. Yeah. Acha. Maybe then it won't do problem that much, but yeah, it's fine. Okay. Then don't connect in that. Don't connect that rusted wires. Have you connected like this? Now we are going to do what? We are going to rotate the servo from 0 to 180 and from 180 back to 0. Okay. So I'm just going to take this line and to write over here again. So it will start from 180 now and it will decrement every time. So I'm saying if pose is greater than what? 0. So until it reaches 0, it is going to decrement. Pose minus minus. And S1 dot right. So I'll just start this. You see, it's going to 180, then back to 0. Can you see? Just upload this code. Yeah. Which code? This was the only last class code. Last class we used this code only, no? Have you uploaded it? It's upload like it's done uploading, right? Okay, wait. What pins you have connected the Arduino to the servo motor? No, no, no. Red wire is connected there of the servo motor. Yeah. What about the brown wire and this orange wire? Okay, this connection is fine only. Just check whether you have uploaded the code correctly or not. Upload this code which I've sent just now. Upload this one. Okay, Roshan. Yeah, yeah. So upload the code which I've sent now, just now. Okay, now it will do a smooth motion from 0 to 180 and 180 to 0. To have a smooth motion all the way around, you need to upload the code which I sent you just now. Okay? Yeah, Sai, you were asking something? Sai? Yeah, tell me. Yeah, are you able to copy it? Okay, I will send in the WhatsApp. Yeah, because the code is already installed in, like you have coded the Arduino. Now the code is saved in the Arduino. So it doesn't matter whether the Arduino is connected to computer or not. Yeah, yep. Instead of, yeah. You can put that also. Because right now we don't want to connect it permanently. Yeah, this delay, can you see the delay here in the code? Delay 50. If you just reduce this, the speed will increase. So if you are giving less delay, angles will be covered more quickly, right? If I'm giving a delay of 5, speed will increase. Let's see. Yeah, make it 5 or 10. It will increase. If you will increase the delay, the speed will decrease. Okay. Yeah. What 180? Then it will be very slow. You can just put in. Yeah. Yeah, yeah. It will cover very slowly. Hmm? Okay, guys. Now, if it is working for you, what we can do, we can start with the temperature sensor. Okay. So let us start with the temperature sensor. Yeah. So how many? Yeah, you can remove all the connections. So how many basically servo motor you have got in your kit? I think one only, right? Okay. Now let us start with the temperature sensor. Okay. So just get your temperature sensor, and I told you about the temperature sensor, right? How it works and all. Okay. Yeah. Yeah, I will share. Yeah. See this one. This one. Yeah. 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 Let everyone. So all of you got this temperature sensor? Just a minute. Okay. So now you can see there are three pins on the temperature sensor, right? So there are three pins on the temperature sensor. So what you can do, we are going to connect these three pins. So it's I think positive, one pin is negative, and one pin is out pin, right? Just a minute. Yeah. Data is basically output from which you are going to get the temperature value. Okay, so already you know how this temperature sensor works. Is basically this is called a DHT11 temperature sensor. Okay, and just a minute. Can you see my screen? So this DHT11 temperature sensor, okay, DHT11 temperature sensor, it works how when the temperature, it has an internal resistance. Okay, it has an internal resistor. Okay, and it's a variable resistance whose value gets changed as there is a change in the temperature. So suppose if the surrounding temperature is very high, the surrounding temperature keeps on increasing, the value of the resistance changes. The value of this resistor changes. Okay, it increases, the value of the resistor also increases if the temperature, sorry, the value of the resistor get decreases if the temperature increases. Okay, so and if the value of the temperature decreases, the resistance value get increases. So this resistor, this is not a normal resistor which is installed in the DHT11 sensor. It's, you can say, this resistor is particularly uh, able to detect temperature change. Okay, so this is sensitive to temperature change. Just like in LDR sensor, there is a light dependent resistor which is sensitive to change in the brightness of the LDR. In this DHT11, inside the sensor is sensitive to change in the temperature. Okay, so it's like a thermoresistor. The name of this resistor is thermoresistor. Basically, thermo means heat, and resistor is the resistance. So as the temperature changes, this resistance value also changes. So according to the change in the resistance value, you can easily predict the temperature of the surrounding. Let's see how we can do it. So if we just connect the DHT, so you can see the DHT11 has three pins. One is VCC, okay, the other is GND, okay, then final is the out pin. Final is the out pin, and this out pin is will basically connect to any digital pin, and through that the temperature value will be read. Okay, through that the temperature value will be read. So uh, we can't write the scratch value to read the temperature values and all. So what we're, yeah, we are doing the digital DHT sensor, right? I'm explaining that only how it works. So suppose it has a, yeah. Hmm. Yeah, basically it's an analog sensor only. But this, when we are using the normal temperature sensor with three pins, do you remember where we created the resistance divider circuit, and then we, it's analog sensor only. But as you are getting this sensor in a module, right? This blue color chip you are not getting separately. This you are getting installed in a module. So there is inside one chip which is, there is also one IC integrated circuit installed on this digital sensor which is analog to digital converter. Okay. So this analog to digital converter chip is already installed on your sensor. So that's why it is converting analog value directly to digital without the help of Arduino. So that, like, this value is getting converted to digital, that's why you use the digital pin. Okay, any doubts? Negative to GND. Yeah, wires, just connect the wires VCC to 5 volts, negative to GND. Okay, and the out or the data pin should connect to any on the, let's say, pin number 6. Okay, yeah, the male to, yeah, the male to male wire, I guess, or sorry, male to female wire. Okay, so, okay, then connect that those wire only if there is, if they are in the packet. Like they have given in case if you don't have any. So digital pin, this is going to connect it with the digital pin. Why? Because there is an internal IC in which there is already a connection of analog to digital. Like there is already a conversion of analog, yes, analog to digital. Okay, so this chip on the sensor, yeah, then connect through that whatever wire you want. So we have a chip, okay, on the sensor, which is basically an analog to digital converter. Okay, and it converts the analog value coming from the sensor, the temperature value, to the digital value. That's why we are directly converting reading to read this digital value. We are directly using the digital pin. Okay, and we are not going to write the scratch code. We will be using one library called DHT11 library. Okay, so we need to install this library first. Then we will see how to use this library, how to get the temperature data and all. Okay, so is this clear how the temperature sensor works? And also, apart from the temperature, this sensor also reads the humidity. So you can see there is one thermoregister. I told you, na, there is one register inside of it. When the temperature increases, the value of resistance decreases. And when the temperature decreases, the value of the resistance increases. It's inversely proportional. Okay, and this resistance is sensitive to temperature. Okay, so there is one more thing, one more sensor is there apart from resistance. There is one more thing. Okay, it's a small capacitor basically, and it is a something like this. It has two plates. Okay, suppose it has two plates in between. Okay, and this is connected to power supply, and in between there is a substrate, or you can say a plate with very thin moisture on it. Okay, so if there is very much moisture, the capacitor can easily conduct the current from one electrode to the other electrode, right? And if there is very less moisture, let's say if there is less moisture, there is dry environment, or you can say there is dryness between these capacitor plates, this distance is very much less. You can say this distance is in micrometers. Okay, so if there is very less space and if there is very less humidity between these two electrodes, obviously it will not be able to conduct the current very easily, right? Because if there is a humidity, there will be more present of water vapors between the electrodes, and through the water the current can easily conduct. Suppose there is less humidity, there is complete dryness, or you can say there is dryness between these electrodes, so the conduction of the current will be very, you can say, very difficult. Okay, so this is how it measures the change in humidity. How easily it is able to conduct the current is basically how much humidity is present in the environment. Okay, is it clear how the humidity is read? Basically, we are reading the amount of the conductivity, how much easily the capacitor is able to conduct its electricity from one electrode to another electrode, and through that value we are defining the conductivity of the capacitor, and also we are defining the how much humidity is present in the environment. If more humidity is there, conductivity will be more. Okay, easily capacitor can conduct the electricity. If there will be less humidity, okay, then there will be dryness between the electrodes, and there will be no water vapor. So it will be hard to conduct the electricity for the capacitor. So using the conductivity value, it can predict the humidity value in the surrounding. So these two things are there, one thermoresistor and one thermocapacitor. You can say, maybe not, it does not sense temperature, but still its name is thermocapacitor. Yeah, it senses the humidity and this senses the temperature. So this DHT11 sensor basically give you both value, temperature as well as humidity. Yeah, VCC to 5 volts, GND to ground on Arduino, and the data wire it should go to the, no, no, it will be written on the sensor. It will be written something, or symbols will be made. Okay, yeah, plus is VCC, minus is GND, and then the output is the data. Okay. So guys, are you clear with this thermocapacitor, how it works and how it basically sense the humidity? Any doubts to anyone? Guys, are you clear? Ujjwal and Roshni. What about Ujjwal? Okay. So let us start with the actual physical. Okay, all of you connected? Okay. Now anyone share their Arduino screen? Sorry, complete screen. Yeah, share. Yeah. M- Mummy, mummy, oye, look. Open your Arduino. Plus, I said now, plus 254 minus 2 GND and data to pin number 6. Simple three connections. Wait. Yeah, so just click on your tools, manage libraries. Click on the first, expand your Arduino window. No, no, expand your this window, Arduino window. Yeah. So all of you open your Arduino window. All of you are open. All of you have clicked on your tools. Click on manage library. Okay. Then in the search box type DHT11. DHT11. Yeah. Just a minute. No, no, no. DHT11. This sensor, the third one, third one. DHT sensor library. Can you see? Yeah, this. Install, install. No, no, no. Don't change anything. Just click on install. Then you will see one library called DHT sensor library. Yeah. No, no, not the robot one. DS sensor library. Just a minute, guys. I'm getting one call. All of you installed it? Okay. So now click on your files. Yeah, click close here. Yeah, click on examples. Yeah, then can you go and can you see the DHT sensor library? At the end, go down. Go the DHT tester. DHT DHT tester. Yeah, yeah, just upload it. Wait, before this, you need to change the pin. So DHT, it's connected to which pin? It's connected to pin number 5 or which pin you've connected. And also it's a DHT 11 type sensor. Now, first maximize this window, all of you. And just can you see this hashtag define DHT22? Yeah, hashtag define DHT. Okay, okay. So remove this line, remove this line, remove this line, hashtag backspace. Yeah, yeah. Then remove the comment from the first line in which DHT11 is written. Hashtag define DHT table. Remove the comment. Just remove the comment. Don't remove the line. Remove the comment. Yeah. Okay. And then in can you see DHT pin above? Hashtag define DHT pin. Above. Hashtag define DHT pin. Above. Put it to pin number in which you have connected your DHT. No, DHT pin. Below that. Put the pin number in which you have connected your DHT. Yeah, now upload it. Yeah, open it. What error you're getting, Roshni? Are you getting temperature in the humidity value? Yeah, you're getting the temperature and humidity value, right? Okay, you can stop sharing. Roshni, you can share. You can stop sharing with Ujjwal. Yeah, yeah. So it's working for you, Ujjwal. What about Roshni? Yeah. Wait. Roshni, present your screen. Yeah, open your Arduino screen. Click on Tools. Have you connected your Arduino to your computer? Click on Tools. Click on tools, tools, comp file. Okay, now click on upload. Click directly upload. Um, wait, wait. Take out your disconnect your Arduino and connect it again. Then try again to upload. हाँ बोलो. क्लास ले रहे हैं. 15 मिनट में खत्म हो जाएगा. Still, now try to upload. Hmm. Put it to a different USB port. Put your Arduino to a different USB port. Make sure it's properly connected. The blue color cable. Open your device manager once, Roshni. It's in which port? Check your port. Click on the side arrow. Side arrow. It's on port 5 only. Okay. It's been cleared. Then why it's not uploading? Click on tools again. Okay, this is fine. Um, have you connected to a different USB port? Okay, then upload. Try to upload in this one only. Check whether the Arduino is properly connected. The blue cover cable, like the blue cable, is properly inserted into the Arduino. Not the USB side, the other side. The other side of the Arduino, it is properly inserted. Check. Okay, now upload it. Can you close this? Can you connect to a different USB port on the other side of the laptop? Just Sai, what problem you are facing? Go in the DHT sensor library. Yeah, and then click on the DHT tester. Go in the DHT sensor library first. Then can you see two options, DHT tester and something one. Now try the check your device manager again. Okay, first check in which COM port it's there. Then accordingly change the COM port in the tools. It's in COM6, right? Change it to COM6 in the tools. Size just present. It's in the COM6. Yeah, yeah. Just change in the tools. In the Arduino, change the tools to the COM6. Size just presents on screen. Now upload it. What connections you have done? Can you press the button on your? Yeah, I can see your. Open your Arduino. Can you press the button, Roshni? There is one button on the Arduino, reset button. Press that and then upload it. Sai, open your Arduino now. Why you are sharing this screen? Share your complete screen, Sai. Don't share only one. Close the Arduino software and then again open it. Yeah. Click on files. Go in example. Go down. Can't you see the DHT sensor library? Yeah. No, no. Go down. Which you installed? I think you installed the wrong one. Click on tools. Manage library. Type in the search box DHT11. Install this sensor library. DST, yeah. Only I have told you to install this one. Install all. Close, close it. Now go in file, examples. Yeah. Click on DST tester. Change the pin number. Which pin you have connected? Yeah. To which pin you have change it to 6. Okay. Just a minute, Roshni. Remove this comment. Remove this line DST 22 or remove this 22. Yeah. And type 11. Type 11. Yeah. Now upload. Open serial monitor. Okay. Stop sharing. Roshni, have you opened the Arduino again? After closing the Arduino, open it again, Roshni. Still it's not. Still it's not uploading. How you have made the connection? Can you tell me? Uh, hmm. Share your screen once and share that error also which you are getting in the chat box. Copy that error message, send in the chat box once. Acha, I can see what you have done mistake. Hmm. Have you installed the right library? I don't think so. Okay, you go. Wait, click on files. Go on examples. Examples. Go in the DST sensor library. Okay, go click on the DST tester. Go above, go above. No, above. Click verify on first. Click on the tick option. Verify. Verify option. Yeah. Verify. Tick option. Wait. Think I click on tools. Manage library. Type DST11. Yeah. Type DHT11. Don't give space between DST and 11. Yeah. Go down. Install this DST sensor library ESPX. Yeah. Also type remove the DST11 from the search box. Type ADA. Type ADA fruit. Adafruit. Fruit. No. Fruit. Type completely. IT. UIT. T, not D. Wait, let it load. Okay. Give space. DHT. Let it load. Okay. Go down. Yeah. Install this. Install all. Close this. Okay. After it is done, install. Close this. Yeah. Now try to this. Okay. Close this again. You can open this. Close this. No. Click on no. Now click on files again. Example. Go in the DHT sensor library. DHT tester. No, DHT sensor library. Yeah, DHT tester. Yeah. Now just change the 22 to 11 and then DHT pin. Change the 22 to 11 directly. Yeah, 11. Then change the pin above. Click on tools and sorry, click on upload directly. Just to make it. Click on files. Example. Go in this DHT tiny DHT sensor library. Yeah. Yeah. Convert this to 11 and also convert the pin number. Now upload it. Okay, click on tools. Open serial monitor. Are you getting? Okay. Okay then. So you are getting the value, right? The change, cover the sensor with your hand, or maybe just hold the sensor in your fist. Try to increase the surrounding temperature. It will just the humidity and temperature will increase. If you now if you keep the sensor around a cool place, like let's say in the front of AC or fan, or if you just blow on the sensor, the temperature will reduce. Yeah. So we covered the temperature sensor. Okay. Next class we are going to cover the gas sensor. Okay. The gas sensor, and then maybe using the temperature and gas sensor, we are going to make a small project with the LED. Let's say if the temperature is increasing at a certain temperature, the LED will glow. Like this, we are going to make using the gas sensor and the temperature sensor in next class. After that class, we are going to start with the BO motor and the line following robot, which is your last project. Okay. Next class Saturday. Yeah. No, no, it will just, you don't have to blow into it. You will just keep in the environment, it will show you the concentration of the gas, how much CO2 is present, which depends which type of gas sensor it is. So it will show you the concentration of the gas. Yeah, MQTT. So that is, I think, CO2 only. It will detect the amount of CO2 in the environment. Yeah. Okay. Which on Saturday you have? Then at what, like, means, yeah, yeah, Saturday 8 to 9. Okay. Hmm. IR sensor. You've got two IR sensor, right? Yeah. So only we have to detect the. Basically, we are going to detect the floor only. If the line comes, we have to make the robot turn. So accordingly, it is going to detect both black and white. No, no, not like that. It's line following. Basically, it will try to follow the line. How the using the black tape, whatever you have made a line on the floor, it will try to follow that pattern of the line. Suppose in circular shape you have made the path. So using the black tape, electric black tape. So it will just follow that line in a circular way. Depending on what is the path of the black tape, it will follow that. Okay. So okay guys, see you in next class then. Okay. LDR sensor we covered, right? LDR sensor I think we covered. Roshni, have you covered the LDR sensor? Yeah, yeah, we covered in some classes. I think you are not there. Yeah, I will then send you the recording. Okay. So see you in next class then. Okay, all of you. No, no. The timing got shifted. Oh, sorry. Wait. Timing got shifted on which day? I think, yeah, Saturday and Sunday. No, no, Roshni, it's not on Monday because last class we changed the timing. I think you are not in the. You were not present. Yeah, yeah. So it was on Saturday and Sunday. The new timings are Saturday, Sunday. Saturday for Saturday it's 8 to 9 and Sunday 10, 11 to 12. Okay. Okay. Yeah.